all the PPTs or all the lecture notes today. Okay. And also the video recordings. So video recording takes time to process and everything. I will upload everything in Google Classroom by today. Ensure that you have joined the Google Classroom. If not, please let me know. I will again share the link.
Hello.
Yes.
Sir, can you please share the notes?
Yes, I will share today notes and videos, class recordings. I will share today.
Okay, thank you, sir.
Why?
So, is the screen visible? Am I clearly audible? Please let me know.
Yes, sir.
Yeah. So now we are discussing mesh analysis. Okay. Since the last two classes, we are discussing 1.5 class. We are discussing mesh analysis. So the basic idea in mesh analysis is to find out the unknown currents in different mesh. Okay. By mesh, I mean the path have any other closed path inside them. Okay. So you have to find the unknown currents in them. Okay. So we have understood the basic idea that how to identify mesh. Okay. Clearly by seeing also you can identify, but to cross verify have identified correctly or not, we have seen that there is a formula of calculating the number of meshes. It will not say that what are the meshes. It will only say how many number of meshes are there. If you are just visually trying to find out, you can just cross verify whether with the formula or not. So formula is the number of branches minus the number of nodes plus one. So nodes you can identify interconnection of two or more elements. Branches, first you have to identify the nodes. Okay. Then you have to identify all the paths between all possible nodes. So in that way you can count the number of branches and number of nodes. So then you have to directly use the formula branches minus nodes plus one. Again, whatever problems we say, in all we will just again use our own understanding to find out the number of meshes. Okay. Um, so- and in mesh, you apply KVL. So the first step mesh analysis is to identify the mesh. Second step is to assign unknown currents for each and every mesh that you have identified. If it's a mesh one, then you assign I1, unknown current I1, and in clockwise direction. So follow a single convention that, okay, if I will assign an unknown current, it will always be in clockwise direction. So you can do the other thing also, no issue. So the second step is to assign the unknown currents. Then third step, you have to apply KVL in each and every mesh. Okay. Now the main problem was the common elements, between each and every mesh. So just to just revise what we have done yesterday, this is the last circuit we did. This is the case one. So we will also consider various cases. Now, the basic thing we have understood. Now, we will consider various cases, various scenarios where you will face problems. The first scenario we are seeing is that when there is a current source that is there in only one mesh. Okay, it can be in both meshes. We'll go to that. But if the current source is in one mesh, then what will happen? So just by seeing the circuit, you can see that there are two meshes. Mesh 1, okay, you have assigned current I1 in clockwise direction to mesh 1. This is mesh 2, you have assigned current I2 in this mesh 2 in clockwise direction. Okay, so the next step is to apply KVL in. So starting with the mesh 1, what you can do is, again, you have to apply KVL. What you first, before applying KVL, you have to take the plus and minus signs. You have to see the plus and minus sign. So if there is a battery, then it is the job is easy, because in a battery only it will be given which side is positive and which side is negative. Okay, so plus minus is already given. But when there is this resistances, then you have to identify how to assign this positive and negative. So the simple thing I have told you is that for any resistance, if you remember let me just open the PowerPoint where I can write. So the problem is in assigning the positive and negative the signs to any kind of a resistance. You know, if you connect these resistances through like battery, then the current will always flow from, this is the positive, this is the negative side. So the current flows in this direction. So this positive means this and this. So the direct the side in which the current is entering, current is entering on this side, that will be positive. Current is leaving this side, that will be negative. Okay. Uh, so here you have assigned some I1 current in clockwise direction. So same I1 current was flowing. Okay, the same I1 current was flowing through this 4 ohm resistance. So that I1 current will flow from, if it is a clockwise direction, it will flow from left to right, from left to right. That means on this side, the left hand side will be plus, that side will be minus, because of this concept, similar concept. On the other side, again, if you, so you can write this. If you move in this clockwise direction, so let us first start with this battery. That means if you move in this clockwise direction, you are encountering the negative sign first. So minus 10. So it will be minus 10. Then the next element, if you move in clockwise direction, you will encounter the 4 ohm resistance. So that resistance you are encountering the plus sign first. If you are moving in clockwise direction, then plus 4, 1. We have to write the voltage. So voltage V is equal to IR. I is I1, unknown current, and R is the resistance 4 ohm. Okay. Then if you move in clockwise direction, the next resistance you will face is the 6 ohm. But the problem with the 6 ohm resistance is that it is common to both the mesh 1 and mesh 2. That means two currents will be flowing. If this is the 6 ohm resistance, through this part, I1 will be flowing, and through here, I2 will be flowing. Okay, this is a 6 ohm resistance. Now we have to see that, okay, based on whether I1 is greater than I2. Okay, if I1 is greater than I2, then the net current will be flowing net current will be flowing in the downward direction. I1 minus I2, then the net current will be flowing in the downward direction, and the magnitude will be I1 minus I2. If I1 is less than I2, then the net current will be flowing in the direction of I2, okay, in this direction, and the magnitude will be I2 minus I1. But we don't know I1 and I2. These are like variables that we have assigned, whose value we'll find later. So how can we know that whether I1 is greater than I2 or I2 is greater than I1? We cannot know. So there is a convention. That means if you are applying this case KVL in mesh 1, then you have to consider that the current in the mesh 1 is greater than all other currents in the other meshes. So here we will consider, since we are considering mesh 1, we will consider this case. That means I1 is greater than I2. That means the net current will be flowing in the downward direction. Net current will be flowing in the downward direction. That means downward direction means it will be entering on this side, leaving on this side. So this will be plus, this will be minus. Okay, forget about this side. It is for written for mesh 2. This side plus and minus is written for mesh 1. So current will be flowing from top to bottom, or it is entering from this side, leaving this side. Okay, as a result, this will be plus, this will be minus. Yes, yes, Charanjit, please.
Once again, explain why we have to take I1 is greater than I2, sir.
Yes. So if you don't take, then what is the solution? Because you don't, you have to, if you have to assign this plus and minus sign, then you have to know in which direction current is entering. Let us say this is the 6 ohm resistance. Okay, you have to, you don't know whether to give plus sign here, minus sign here, or plus sign here, minus sign here. That you don't know. That how you can know? By knowing the direction of the current. I have already told, if the current is entering from a particular side, that will be at higher potential or positive, and the other side will be negative. So to know which side is positive, side is negative, you have to know the direction of the current. But direction, two currents are flowing. I have already told that 6 ohm resistance here is common to both the meshes. So I1 is flowing in this side. Best I1, you have considered that it is flowing in clockwise direction. That means if you consider clockwise, then current will flow from top to bottom, top to bottom. And I2, you are, again, I2 you have considered in clockwise direction. So I2 will be flowing from bottom to top. So I1 is flowing on this side and I2 is flowing on this side. So how we will know, like, which, if I2, then the net is flowing in down direction. If I than I1, then the net flowing in the direction. But you don't know the values of I1 and I2. How you can compare these two terms, I1 and I2? That's why I have told a convention you can consider that, okay, if we are writing this KVL equation for mesh 1, then we will consider that I1 will be the highest. It is just, sorry, you are assuming, your assumption may be wrong, that you will see at the later. Just you are assuming that, okay, when we will write the equation, KVL equation, the current that particular, if you consider this case, then things becomes easy. Now things becomes easy. If I1 is greater than I2, so definitely the net current will be flowing in this direction, whose value will be I1 minus I2. Then if the net is flowing in this direction, it is entering from this side, so this will be positive. Is leaving from this, so this plus and minus. Okay, if you encounter this 6 ohm resistance from a clockwise direction, then you will encounter the positive sign first. So positive, the value of the resistance is 6. The amount of current is I1 minus I2. That will be equal to 0. This minus 10 you can take on the other side. The other things will remain same. 4 plus 6 I1 minus I2 is equal to 10. Okay, that's why. And in mesh 2 becomes very easy. If there is a like current source in a particular mesh, then things becomes very easy. Okay. If there is a current source, then what does this current source do? Current source ensure that that much amount of current should always flow through the circuit. Okay, so if it is a 5 ohm current source, then it will ensure that 5 ohm will flow through 5 ampere current will flow through this 6 ohm. And in this junction, okay, it will, and then it can be added or subtracted, anything can happen. But at least you can say that through this 3 ohm resistance, current 5 amp will be flowing. If that is the case, then you have already considered some value I2 and in clockwise direction, but this I2 is in opposite direction. If you see this I2 that you have considered, it is flowing from top to bottom, but the source that is given to it is 5 ampere that is flowing from this downward direction to upward direction. Okay, so definitely I will be equal to 5 ampere because this is the independent current source, which will always ensure that okay, 5 ampere current flows through this, at least this branch, and this the current through this branch you have already considered as I2. So definitely I2 should be equal to 5 ampere, but you can see the direction that you have considered that is in opposite direction to the that is being shown inside this independent current source. That's why the negative sign will be there. Okay, because your assumption of the direction of I2 was wrong. Okay, that's why minus sign will be. It is not wrong, but it is being corrected by analysis. Okay, so I2 will always be 5 ampere. So if I2 is ampere, we've already got one equation that is 4I1 plus 6I1 minus I2 is equal to 10. That we have already considered. Here the unknown two things, I1 and I2. But I2 that is, so 4I1 plus 6I1 that is 10 minus 6 multiplied by I2. So 6 multiplied by 5, 30. 30 and this minus sign and minus sign will become plus, that will become 10. Okay, so I1 will be equal to minus divided by 10, okay, or 2 ampere. So I1 is equal to minus 2 ampere. That means the magnitude is 2, but the direction is in opposite side. Direction is in anti-clockwise direction. So now if you see the 6 ohm resistance that we are talking about, so what we have considered, see that okay, I1 is flowing in this direction. Now I1 we have minus 2. So what is happening? I1 is flowing in this direction, that is 2 ampere, and I2 is flowing in this direction, that is 5 ampere. So the net current through the 6 ohm is 5 minus 2, that is 3 ampere, and that will also be in downward direction. Okay. So whatever direction, whatever assumption you do that okay, this current is greater than that, and everything will be corrected. If your assumption is wrong about that current, you will get a minus sign before that. Okay, that will show that what is the correct direction. Okay. Now, next concept is very important and a bit tricky to apply. If you have any doubt before this part, otherwise, this is a very important concept for your GATE examination and all. It is a concept. Yeah.
सर इन प्रीवियस क्वेश्चन जो करंट वाला था उसके पहले वाले में सर इन मेस 1 वी हैव टेकन द नेट वन रेजिस्टेंस एज I1 minus I2 and in मेस 2 we have taken I1 so we can alternate.
Yes, you can change on.
We can change the cases.
Yes. You, but the change will only if it is a like two junction, means that particular element is being is a common to only two mesh. And is a common to three element, three mesh. Then how will you take the assumption? When you are considering, let us say mesh 1, okay, I am telling you to consider that I1 is greater than I. Okay. But you are saying that, okay, in mesh 1, I will consider I2 is greater than I1. Okay, fine. It's fine when this element, that 6 ohm resistance is common to only two mesh. Let us say there is some kind of a circuit where the 6 ohm resistance is common to three circuits. It's difficult to show it in a like two-dimensional manner. Let us, if circuit. So it is only for the person who has asked the questions. For others, if this has question in mind, it's not required to like try to understand, because it will be you will feel complicated. Okay, yeah. So let us say if there is some kind of this kind of a resistance, 6 ohm resistance. So say 6 ohm resistance. So this is a common to, let us say there is some kind of a loop here. Okay, some kind of a loop. Some battery is there. Again, there is another loop like this. Source is there, let us say, and source is. And in 3 dimension, it can also common to, let us say, another loop. So in this mesh, you are considering I1. Okay. In this particular mesh, you are considering I2. In this mesh, in 3 dimension mesh, you are considering I3. Now, what will you do? Let us say we are writing the KVL equation for mesh 1. Then which current you will take the maximum? It's better to take I1 greater is the highest. Otherwise, you have to take the combination that I3 is greater than I1 and I2. Then when we will consider this third mesh, say this is mesh 1, this is mesh 2, this is mesh 3. If you consider, okay, I3 is the highest, then what? The same thing, then while you have to remember C is the highest. So while analyzing or writing the KVL for mesh 3, you have to ensure that you are taking I1 as the highest. Okay, so that kind of thing will come into picture. That's why it's better to always take, if you are writing the KVL equation for a particular mesh, consider that the current in that particular mesh is the highest one. Okay, then this case will not happen. Two mesh, it's okay. That means a common element between two mesh, it's okay. But it's greater than that, things will become complicated. That's why it's better to use the same convention. Clear?
Okay, sir. Thank you.
Now, next, we are considering super mesh. So, problem in super mesh? Super mesh happens when, again, there are two meshes, and you are seeing that there is a common element, and that element is also the independent current source. It can be dependent also, but it is an independent. So, if when common between these two meshes or more than two meshes, then this concept of super mesh comes into picture. You cannot um, solve it using the previous. That means the initial step same. That means you have to identify the mesh and current to the mesh. That things will remain same. Now, while writing KVL equation, you will face problems. Okay, you will. That's why a bit different, different, but you will understand. Okay, so let us consider this circuit. That means just by visual inspection, you can see that there are two meshes. This is mesh. Okay, and mesh. So you have considered, okay, current is flowing through mesh 1 and I2 current is flowing through mesh 2. And there is a common 5 ampere current source, both mesh 1 and mesh 2. Now what you have to do? You have to remove this. You have to remove. It is the same circuit. It's the same circuit. But what we have done, we this 5 ampere current source. We have removed this 5 ampere current source and we have merged these two meshes. And by merging, by removing that, what happened? The difference between these two elements have gone. That is, the distinction between these two elements has gone, because this current, this 5 ampere current source dividing these two meshes. Now that you have removed. So these two meshes have, you can consider it like this, that these two meshes have merged together and created a mesh. Okay, but writing the KVL, now you have to apply KVL. Only this was the different part. That means when there is a common current source between two meshes, what you have to do? You have to remove it, and by removing it, what you are doing, you are creating a super mesh. Okay. Now we have to the next part remains same, that you have to write the KVL equation. But write the KVL equation, because upper mesh, you have considered the current I1 is flowing. In the lower mesh, you have considered that the current I2 is flowing. Okay. Now we have removed it, but that same current I1 and I2 that considered. Okay. So how to write the equation? So simple. You have to look at anything. You have removed. So let us say this is the So earlier there was a distinction here. Okay, there was a distinction here. There was a current source that you have removed. That you have removed. But you have removed that. You are not considering that. But what you have to do? You have to consider a ideal imaginary line, imaginary distinction or difference here. Okay, imaginary line that divides these two mesh. Okay, that divides the super mesh into mesh 1 and mesh 2. That you have to write. Why? Because let us say again, for applying KVL, the same concept apply. You have to go in clockwise direction. Okay, so let us say you start with this, then you will go to this 6 ohm, then you will go to this 12 ohm, then it's 12 volt. In this way, you will go on. So whenever you will try to consider an element, that means what is the current flowing through that element. Let us say this 6 ohm resistance, then which current you will consider? You will consider that current that was there. Let us say this imaginary line is there. So all the elements above this imaginary line belongs to mesh 1. All the elements that is below this imaginary line that belongs to mesh 2. Okay. So while writing the current that is flowing through the elements that are in mesh 1, you have to consider the current that you have considered for that particular mesh, that is I1. When you are writing there, okay, how much current is flowing through this 12 ohm, you have to write I2 because that is the current that you have considered for mesh 2. Okay, so you have removed the common element, common current source, but you have to consider there is a imaginary line that divides this super mesh. So when you are writing the equation, KVL equation for any of the elements in the top half, this one, then you have to consider that it belongs to mesh 1. Okay, that means through mesh 1 you have considered I1. So the current through this 6 ohm resistance, you have to write 6 I1. Okay, again the current through ohm resistance, this belongs to this mesh 2. Okay, so the current through this 12 ohm resistance is I2. Okay, so that is the only thing here. Now, based on that, can we start writing equation? Okay, let us start with this. Let us start with this 15 volt voltage source. We will move in clockwise direction. So if you move, so before that, plus minus sign. So plus minus sign, the current I1 that we have considered is flowing in clockwise direction, this direction. So it will be flowing from top to bottom. So current is entering on this side, plus sign. Current is leaving this side, minus sign. Again, I2 you have considered this. That means I2 is also flowing from this side. That means I2 is entering this side, leaving this side. So this is positive, this is negative. So plus minus sign you have considered for voltage sources, plus minus sign is already given. So moving in clockwise direction, we are trying to write the voltage, the KVL equation. So moving in clockwise direction, you are encountering the minus sign first. So minus 15 volt. Okay. Then clockwise direction, you are encountering 6 ohm resistance and you are encountering the plus sign first. So plus 6, what is the current? You are writing the voltage. Voltage V is equal to IR. So you resistance value by the current value. Current value, what is the current flowing through this? I1. Then in clockwise direction, the next element that you're seeing is 12 ohm resistance and you are encountering the plus sign first. You are encountering the plus sign first. Plus, and what is the current flowing? I2. Encountering this 12 battery and you're encountering the negative sign first. So minus of 12, that will be equal to 0. So 6I1 plus 12I2, that is equal to 15 plus 12, that is 27. Minus 27 is there. So you can take it on the other side. So it will be 27. So this equation, 6I1 plus 12I2, that is equal to 27. Now there were two meshes. You have already removed the distinction. Two things have merged. So there was a single super mesh. You have written the KVL equation for the super mesh. The work is done. Now you have to write the relation between I1 and I2. Definitely there are two unknowns, one equation. So you will not be able to find out the value of I1 and I2. So you need another equation, at least another equation. That is what is the relation between I1 and I2. Now if you see, let me just take a snapshot of this. From where will the next equation come? That's the n. Okay. The next thing will come from the convention that we have followed in giving the direction of I1 and I2. I1 and I2 is still unknown, but the direction you have already fixed. That is, I1 is flowing in clockwise direction, I2 is flowing in clockwise direction. So you have to see here for this 5 ampere current source, in which direction I1 and I2 is flowing. I1 is flowing in this direction. This is I1. I2 is flowing in this direction, that is I2. But based on the given current source, the net current, that means net current will be 5 ampere. Net current means it is either the difference between I1 and I2 or the difference between I2 and I1. Based on which one is greater, we don't know which one is greater, but the current source is giving that information. Okay, the net current, the magnitude of I1 and I2, that is equal to 5. But what is the direction? So the net current is flowing in this direction. So definitely this is the direction of I1. So you can conclude that I1 is greater than I2. Okay, so I1 minus I2, that should be equal to 5 ampere. Please let me know if you have any queries, how we are finding out the next equation I1 and I1 minus I2 is equal to 5 ampere. Now from here you can easily get, okay, I1 and I2. So I1 will be equal to 5 plus I2. That you can see. Okay, so that you can see. Is it clear? Okay, someone is question. So can't we apply KVL separately? You can apply, but then you will get two equations of I1 and I2. Okay, and how will you write this? Because as per our previous example, if there is a current source in a particular mesh, the current in that mesh becomes equal to that current source value. Like let us say here, for the mesh 2, you have considered I2 to be of value 5 and the direction is an opposite direction, so minus 5. Okay, now in this case, what will you consider? This current source is common to both these two meshes. So you cannot consider that, okay, I1 is 5 ampere, I2 is 5 ampere. But that is definitely not the case, because this 5 ampere will be the result of the difference between I1 and I2, and you don't know I1 and I2. So how will you find it? How will you write the KVL equation? How will you write it here? How will you write it? When you encountering this source, it's okay. You can see that whether plus and minus and what is the voltage. Okay, you can. 6 ohm also you can write. Okay, 6 multiplied by I1, you are encountering the plus sign first. Okay, plus 6 I1. Then what about 5 ampere? Because 5 ampere is a current. There is no element here. You cannot find out the voltage. That means the only way out is to consider that I1 is equal to 5. Then what will you consider about I2? I1 will not be the same. Then the net current will be equal to 0. So there are many contradictions. So that's why you cannot apply KVL separately. You can try. You can try to apply, but the problem will come whenever you will face this 5 ampere current source. Okay. Is it clear? Yeah. So you have got two equations. I1 minus I2 is equal to 5, and this equation, then two unknowns, two equation, you can just solve it, okay, and you will get the answer. So this is the concept of super mesh. Okay, most probably in most of the circuits you will get the super mesh where the common current source is shared by two mesh. Okay, not three mesh. You will not get those like three-dimensional circuits are difficult to. Okay, so just think about it. 1 minute or 2 minutes. I will take some water and I will come back. In the meantime, just think about this. Okay, if you have any doubt, I am keeping this slide open. If you have any doubt, please let me know. Okay. Yes. So, sir, what is the unit name of this? This is the first unit. This is the first unit. This is the first unit of circuit analysis, where we learn about the basic circuit theorems and everything. Okay. So, if the current source contains a resistance connected in, now this is a fundamental mistake that we are making. Okay. I have already told you. Okay. What I have told you about the independent current source and voltage source. If you remember, what is the value of resistance for an ideal independent current source? What is the resistance value for an ideal independent voltage source? If you remember that thing, you will never ask this question. Which book should I prefer for this unit? See, as per the textbook, the Sadiku book, okay, the Sadiku book, that is important. This is standard for if you are preparing for GATE, that is a standard book. Okay, there are also many Indian authors' book, okay, which are not mentioned there. I will share one such book in the group. Okay, then it will be easier for you. Okay, there is a book of circuit theory by Abhijit Chakravarti. Okay, it is a very old book. We have also read from this book. So, standard book also. But for GATE purpose, if you are eyeing for GATE, you have to definitely one time you have to read the Sadiku book. That is the first book that is given in the textbooks section. Okay. I will send it in the mail. The Sadiku book, it is available in the library. When you will come, you will definitely get the hard copies. Okay. For the Indian author book, I will share it in the mail. Sorry, in Google Classroom. Sir, can be taken if I2 minus I1, if we consider I2 greater than I1. Which one? In this problem? Okay, first I have to answer the question of Arin. Okay. So if you remember this, let me just open the notes, then it will be easier for you to remember it. This. So what is written here? Ideal voltage source has zero internal resistance. ideal current source has infinite internal, the answer lies here. The ideal current source has a infinite internal resistance. So let us say this was the mesh one. So there is a voltage source, there is a resistance, and there is this current source that is given like this. And you are telling that, okay, why can't we, well, what would happen if we consider a resistance here? I think that is the question. Again, there is a voltage source, there is a current source. This is 6 ohm, this is 12 ohm, this is let us say how much let us say 12 volt, and this is 15 volt. Okay, so the question of Rn is, why can't we consider a resistance that is connected in series with the this current source? Now see, while analyzing the circuit, we will always consider that, okay, whatever source is there, that will be ideal. In practical, we will do the modifications later. But for this subject, let us consider, whereas we will consider that everything we are considered ideal. The resistance are also not ideal. The voltage sources are also not ideal. So if you consider that kind of a practical circuit, then the analysis will become much complex. Even for this small problem, it will be since we are considering resistance current source is very high, very high. That means you can consider it as like an open circuit. That means infinite resistance. Infinite resistance means this one. It will allow the current outside its, but the resistance is like this. So its resistance value is infinite. Okay, two resistances. This is a resistance of infinite value. This is let us say resistance of value R. So these are in series. So if you add infinity with R, what will be its effect? Infinity. So this resistance will not come into picture. This resistance will not come into picture. The resistance of the current source will be the dominant one. Similarly, if you consider a voltage source, the same question you can apply, you can ask me when we will study nodal analysis. That means there is a voltage. There will also be a concept called supernode and everything. So you will may ask, so what happens if we apply resistance in parallel to the voltage source? So resistance in parallel to the voltage source, if we apply, what is the resistance of this voltage source? It is 0. That means is in terms of resistance, this is close. That means it is like a simple conductor. So if the current is flowing from here, it will not divide into two parts. The current will always choose the path with the lowest resistance. So the whole flow through the path with zero resistance. So this resistance will not come into picture. So what is the main conclusion? That you cannot just, if you even connect a resistance in series with a current source or a resistance in parallel with the voltage source, it will have no effect because of this reason. Is it clear, Arin? Let me know. It is a very important question. Yes. So it is a very important question. In multiple subjects, you will face the same thing. In circuit, wherever in subjects there is a concept of circuit analysis, you will face the same thing. Okay. Now, the next, Rajbir is saying can be taken I2 minus I1 if we consider I2 is greater than I1 for the super mesh. In super mesh, how we can consider like? Let me see. In super mesh, by just seeing this value, this current and direction and the magnitude of the current, you can say that the direction is in the same direction as I1. Okay. No, if you consider this in counterclockwise direction and everything, then things will become, then it is okay. Then what you are telling is okay. But if you are using this convention that the current in all the meshes you are considering as flowing in clockwise direction, then whatever is given is correct. But if you say that, okay, I2 is in counterclockwise direction, I1 is in counterclockwise direction, then definitely I2 will be greater than I1 based on the direction you are considering. Why? Sir, we take infinite resistance for a current source. So it is how this current source behaves, one thing. Like the main idea of a current source that it will ensure that that much amount of current flows, okay, through its two terminals, okay, through its two terminals. So that is how our ideal current source behaves. Similarly, a voltage source, which is in a circuit, is connected in series. Okay, if you see any kind of a any kind of a circuit with a voltage source in it, so you will see that voltage source is connected in series with all the elements. If you are connecting a source in series with all the elements, and you are telling that, okay, let us first consider the case of voltage source. So voltage source we are considering zero. So same question you will ask that, okay, why we are considering zero resistance for a voltage source? Okay, let us say that it is not zero resistance. Okay, it has some finite resistance. So what will happen? So let us say the voltage source that you are saying, so you are saying that the voltage source that you have connected plus minus, let us say, or let me just draw it in a bigger manner. So this is a voltage source. So this isn't connected in series with resistance and all those things. Let us say multiple resistances are there, and the plus sign and minus sign is there. Okay, and we consider that it has zero resistance. Let us say you are saying that, okay, it do not have zero resistance. There is a finite resistance that is connected. There is a finite resistance that is connected. So will result into some amount of current. Let us say current I. Okay, the same current will then go through this resistance. Let us say this is small r, some finite resistance. Same resistance, the same amount of current flow through this resistance. So what the voltage drop? So this, the aim of this voltage source is to supply energy. But because there is a finite resistance inside this voltage source, what happened? It will also consume energy. So it was the main aim was to give, let us say, V volts, let us say 10 volts. But due to the small resistance inside it, this R multiplied by I will be the voltage. If this is plus, then this will be the minus. So as a result, the voltage output of this voltage source will be 10 minus Ri. That means you are going to, let us say, go to the market to buy a battery. Okay, pencil battery, 5 volt. So you have asked like, give me a battery of 5. But because of this small infinite finite resistance, actually the voltage will be far less, and that will be also dependent on current. If you are drawing huge amount of current, let us say you are drawing 10 amperes, is very small, but I is very high, then Ri will be also very high. Okay, the Ri will be stable. That means we will not be able to get any kind of voltage. Sir, if you have infinite resistance for the current source, then it acts as an open circuit. No, it ensures that current flows. Okay, but it doesn't. The resistance is not connected. The resistance is like this. The resistance is like the resistance that is connected in current source, that has huge value. Here, the resistance that is inside a voltage source, because voltage source has also, it is a power supply. It has also many components. It will have small amount of resistance, but an ideal one, the resistance should be equal to zero. Again, current source will also have different components using which you will create the current source. So all these components will have some kind of a resistance. So ideally it should have infinite. It will have some finite value. Ideally the resistance in the internal resistance. These are called internal resistance. Internal resistance of the voltage source. Internal resistance of the source. Okay. So internal resistance, ideal value for a current source is but definitely it will have some finite value. If not, let us say you are buying a current source, you are saying that, okay, that source should supply me 10 ampere. But if it is not the case, that means it has some finite resistance value, then what will happen? It will not be able to generate this amount of resistance, this amount of current. So 10 minus some voltage will be across this. So V divided by the small resistance, the finite resistance. Okay. So you will get this much amount of current. If R is very high, you can say that if R is very high, then this part will be negligible, this part will be very small. Then you can neglect this part and you will consider that, okay, the current source will give you this much amount of current. Okay, so ampere minus value, and across this whatever circuit you have applied, there will be some kind of a voltage. Let us say voltage V. If R is infinite, this term you will not consider, and the current source will behave as a 10 ampere. If R is finite, then V divided by R, it will have some finite value, and 10 minus value, you will get some less value, 9 ampere, let us say 5 ampere. So it will be not desired. Okay. Yeah. Now, the case 3. I'll just motivate it because there is not much time left. I'll just motivate this case to you. Okay. Consider there's a dependence. Here you can see the circuit. There is a dependent voltage source. If again you have to see the diamond like sign, that means it is dependent. Inside the diamond like sign, you have to see whether plus sign is there, plus minus is written, or arrow is given. If plus minus, it is a dependent voltage source. If the arrow sign is there, it is a dependent current source. Now you see written beside it. Here it is written 3ix. That means it is dependent. I means current. It is already shown. I is shown by this arrow inside this branch. That means I denotes current. So this dependent voltage source depends on some kind of a current. So it is a current controlled voltage source. Similarly here, it is a, you can identify it is a dependent current source, and it depends on voltage Vx. And Vx is shown, Vx is as this plus minus sign across this 56 ohm resistance. That means it is this is a dependent current source, and it is dependent on voltage. So it is a voltage controlled current source. Okay. So first hurdle we have okay, that means we have identified that whether what type of dependent source it is. Now this dependent source is there, and then again you can see the mesh 1 and mesh 2. Okay, you can see the mesh 1 and mesh 2. I1, then for the two meshes you have to assign unknown currents. So I1 we are assigning for mesh 1, and I2 we are assigning for mesh 2. Done. Till this part it's okay. Now we have to apply KVL. We have to apply KVL. Let us consider that you are applying KVL. So before that you have to see how this is related. Now what is the relation with this? Since you have given the direction of I2, so I2 will be flowing from this to this side. This to, it will be entering from this side, it will be leaving from this side. So across this 56 ohm resistance, according to your convention, this will be plus, this will be minus. But in the problem, it is opposite. Okay, so this is Vx. So your convention can be wrong, can be right. I don't know. Because you have considered, okay, I2 is flowing through here. We are considering the side. So what will be the voltage drop? This, it will be I2 multiplied by 56. 56 is the resistance value. I2 is the current that you have considered. So this will be the voltage. Okay. So 56. So according to your convention, this is the direction. But in the problem, it is given, okay, Vx is defined like this. So Vx is the opposite, is in opposite direction to what you have considered. So Vx you have to write, Vx will be minus of this. Vx will be minus of this. Now, what is this value of? Okay, so Vx is minus 56i. Okay, minus 56i. Now you apply this KVL in mesh 1. So in mesh 1, there is a current source. It is dependent, but it will act as an independent, as we have seen. That means I1 will be equal to, it is in the same direction as this dependent current source. So I1 will be equal to this amount of current. That is, I1 will be equal to Vx by 2. Vx by 2 is the current. Okay, current value. Definitely it is dependent on something, but it is the current value. So I1 will be equal to Vx by 2. Okay. What about mesh 2? In mesh 1, you don't have to do anything else. I1 you have already got Vx by 2, and Vx you know that this is the case. That is, Vx is equal to minus 56 I2 divided by 2. So you can find out what is the relation between I1 and I2. So one equation you have got. But there are two unknowns, I1 and I2. You cannot solve it using one equation. So you need another equation. For that, we will write the KVL equation for mesh 2. Again, you have to move in the clockwise direction. Start from this 200 volt. So you are encountering the minus sign first. So minus 200 volt. Then you are encountering, according to your convention, forget about this. According to your convention, this is plus, this is minus. So you are encountering the plus sign first. So plus 56 I2. Okay. Then you are encountering the 28 ohm. Now 28 ohm, you don't know whether I1 is greater than I2 or not. So we are considering mesh 2, this mesh. So we consider that I2 is the greatest. So if you consider I2 is the greatest, so net current will be flowing in this direction from the bottom to top. That means this will be plus sign, this will be minus sign. So if you are going in clockwise direction, you will be encountering the plus sign first. So it will be plus 28, and then it will be I2 minus I1. I2 is the greatest one. So I2 minus I1, that will be equal to 0. 200 you can bring on this side. 56 I2 plus 28 I2 minus I1. Okay, and the relation between I2 and I1, you have already got it here. You just replace it on this equation. You will be able to find out what is the value of I1 and I2. Okay, so we'll end this discussion here. Till this part, I will send you the notes definitely by today, and also the lecture, lecture recordings, so that before we again meet on Monday, before that, you go through all these concepts, because things from now on will become a bit difficult. Okay, the complexity will increase. So if the basics are not clear, it will be very difficult for you. So just work on it. All these slides, each and every line, go through it. Lecture notes repeatedly, you see lecture videos, and whatever your doubts are, is a 2-hour session on Monday from 3 to 5. So we'll have enough time to discuss all your doubts. So today is 22nd. I'll take the attendance. A Vishnu. A Vishnu is there, is present. Akash Rai is there. Akash Rai. Akhil. Akhil is there. This is your first class, Akhil. Anag. Anag is there. Okay. Apurva Sinha. Apurva Sinha. Arin Agarwal. Arin Agarwal. Charanjit.
Thanks, sir.
Yes, I've given that. Charanjit there is there. Devanshu is there. Devanshu. Sorry. Devanshu is there. Kotsame is there. Kotsame is there. Manisa. Mayank. Mayank is there. Nelson is there. Okay. Potigat. Potigat is there. Pratik Raj. Pratik Raj. Rajveer Rawat. Rajveer Rawat is there. Sasi Sekhar. Sasi Sekhar is there. Shreya Yadav. Shreya Yadav is there. Okay. I have taken your attendance. So I'm just calling out the names. Please let me know if I have mixed your attendance. Akash Rai, Anak Krishna Singh, Apurva Singh, Arin Agarwal, Devanshu Sharma. It is Korsame, Manisha, Charanjit, Mayank, Nelson, Pothigari, Rajveer, Sasi, Shreya, Akhil, Pratik Raj, Vishnu. Okay. If you're given an attendance, you can leave. You can leave for the next class. It's time. Okay.